Something I've been planning to do for a while is to make a split phase leaf motor. Now, you can see some of these got a little bit of corrosion and stuff on them. It's pretty normal. A lot of these, I think all four of my motors, or at least two or three of them, are from flood cars. I think from Hurricane Katrina a long time ago, actually. Nonetheless, you can see how each phase wire is from a group of two wires into the same lug. Um, so basically, the plan is to split that apart and put basically the same lug on, so we can overlap it and run it with one controller for the time being, but split it and run two separate controllers run into them. Only as long as underneath here, I believe, should be our Y termination, which is actually probably two Y terminations grouped together and crimped. So as long as I can figure that part out, I'm gonna have to cut that open. Then I can split these, and I can have two electrically isolated sets of stators inside the same housing. What this does is lets me run two motor controllers, two axioms, feeding as much power as possible into two sets of wires. Now, there isn't a huge thick wire here, but I can modify the case so that what comes from here out is really thick, probably a huge wire anyway, as thick as possible. But I think this has a lot of potential. I've done this in the past with the Zero motor, and for burst rating, I was able to do an incredible amount of power. I think the highest I hit was at 87 horsepower on a 0.75.7 with two Sevcon size 4s, and I know I could have hit it harder with two size 6s. So there's a lot of potential, and for a drag race motor, that's going to be the ticket. Once I figure that out, the next step's going to be to pot this. So stay tuned. I'm going to keep working on this and see if I can take this apart a bit, pot it. Once I get that stuff done, I'm going to clean it up. What I figured out was I got a little bead blast gun I used before with some baking soda, because it's actually pretty gentle, but it cleans the aluminum. I actually used baking soda mixed 50-50 with water. I stirred it up, poured it right in the pot, and it's like your cheap $20 sandblasting gun. And I did it outside with some safety glasses and stuff on, and man, it actually worked nice. It doesn't even hurt your skin when it bounces back like sandblasting does, and it leaves a really nice looking factory finish. So I'll do that. That'll be the last step. First things first, I want to spend some time seeing if I can split the phases on this, because that's going to be key to making big power from the rear motor in the CRX. As I thought, I would find a Y termination hidden under this, basically under this big chunk of silicon tube or whatever it is, basically just to protect it, isolate it and everything. I'll probably save this and sorry, put a layer, maybe slide this on when I'm done, put a layer of heat shrink on before and after or something, but nonetheless, that seems good. So now I gotta either crack that open or cut just on that side of it. I prefer to crack it open and split the sides apart so I can figure out which is which. So it means I need to open these up as well, so I can isolate the two blacks, the two whites, and two reds or oranges, whichever color. And then split these apart and use a multimeter and figure out which one has continuity, so I can figure out phase ABC for side 1 and side 2, essentially. One thing worth pointing out is I did use a small cutoff wheel on my drill to cut down the side of one of these to see if I could split it open a bit, and I've managed to get it. When you have a proper crimp, the crimp lug, which is typically copper, and all the copper wire all become one molten, I don't know if molten's the right word, but one solid piece of copper. And so basically, if we look in there, you can see it was pretty good. It could probably have been a little better from factory, but I'm trying to hold it so we can actually get a good close-up on that. But nonetheless, you can see, if I can get it to focus, get my phone to focus here. You can see just trying to put my fingers behind it so it'll focus. There we go. You can see the piece of the strands, the individual strands inside are actually squished down to where they're basically, it was more or less square. So if we did a cutaway, zoom back out, a cutaway on this angle and polished it, you'd actually see it was more or less one continuous piece of copper. You can also tell by the top how far down the corrosion went from, there's a bit of corrosion on the end of the windings, but it actually didn't go very far down. It only went maybe a couple millimeters past, like it stopped more or less where the actual crimp indent is. So that's actually probably not a bad crimp, but it's something to look for when you're doing proper crimps, because I know people who think that you could put some solder in there, or you could add solder later on, and I've had friends in the aerospace industry do cutaway views on those, and when they're done properly, it's one solid piece of copper. There's nothing that's going to conduct better than that proper crimp. You actually can see from how hard it is for me to get these little strands of wire pried away from the actual crimp itself, that it was actually a really good crimp. They're quite challenging to get pried away or split away or whatever you want to call it, because they basically became one piece of the lug. I'm going to look at what I have for crimps and what I can get. I think I can find something longer, so I can just cut these off and start a little lower and extend it out that way. Because this is going to be too time consuming, and I don't trust what I can do after I'm done. I just thought I would cut one open and see what kind of success I would have. I can see one thing. I actually think I figured out something. This will be enameled wire, because although individual windings need to be isolated from each other. So I believe what they do when they actually crimp these at Nissan, whoever makes their motors for them, is they probably have something that crimps and heats it super hot at the same time. It kind of burns the enamel away from that cross section there. And you can see evidence of this on the other phases here, if I can get it to focus, where some of the enamel goo kind of bubbled out. And I was wondering what that was at first. Now I think I figured it out. So I open this one up, I am gonna try and peel them out, and what I'll probably do is just take a razor, scrape down a little further, and then I'll see if I can get a crimp that slides on with a longer shank on it, so I can grab as much of the copper continuity as possible, so that I don't end up with unwanted resistance in my crimp connection. Another thought is maybe I could find a way to superheat everything as I'm doing it, or a chemical I can remove the enamel with. So I'll probably get this one popped out. I actually might do all three of these and the Y termination, because I'd like to just double check before I order anything that this well split the phases. I'm 99.9% positive it will, but I'll get that all ready first, double check with an ohmmeter, and then basically see what I can find, if there's any chemicals that would be good for this, or if there's a better trick, so that I can reach down. I'd like to get the copper windings are a little compromised here where I've opened it up, because it's already been crimped. So I'd like to just cut the insulation back a little further and slide a lug back a little further with a crimp it down a little further, so I have a really good connection, because this will be the motor I'm pushing as hard as possible, so I want those to be absolutely perfect. So after messing with the first one quite a bit and getting a lot of broken strands down further, because it was crimped really well, which is a good thing. It means the factory crimps are really good on these things. It became one solid lug of copper like you want it to. I decided to get the cutters out and just cut the other ones off. So now I've got my phases separated, and what I thought was a Y termination, but I have to look, because if there's only 4 in total, that, I don't know, I don't understand how there could only be 4 for a Y termination, unless there's like maybe 2 more over here, but still, they were all connected together, these 4, so I'm going to test this now with a multimeter, and I'll know more soon. So I ran into my first, maybe my last snag too, depends how this goes. After taking the first crimp off that I thought was a possible delta connection. I quickly found out that I'm just trying to find one of those things that I could cut off there. Quickly figured out that that was not the only one. There was one on both sides. So either way, it had a group of 4 of these green insulated, and I could peel that off because that's inaccurate at this point. It had 4 of these sets of strands of wires grouped together and crimped, and then it had another 4 on this side. So then it started, and then it had our 2 sets of phase wires crimped together in each lug on this side. Well, even 4 times 2 is 8. That's not divisible by 3. So I started ohming them out and trying to use the multimeter to prove which ones were connected where. And then I started realizing I got all kinds of connections I didn't realize I had. So I quit labeling them at that point. But I pulled off the green off of one of these and traced it back and realized that it's 2 separate groups of windings. So now I've got that figured out. So that puts me at 4 times 2, because there's one on each side, one of those crimps on each side, would put us at 8. And then we got 2 groups in each of those, so that puts us at 16. Still not a number divisible by 3. So I'm trying to understand the connection, because typically, like with a Y wound motor, you'll have a Y termination in the middle. So you'll have your 3 phase wires, or sometimes 2 groups of 3 phase wires, and then you have 2 Y connections in the middle. With delta, it would do it differently, but it's still going to be a number divisible by 3 as far as I'm concerned. So I'm trying to understand that part. It might be some sort of neat trick that they did, kind of like they used to do. If I can find it here, I just saw one for connecting motors when you have like industrial motors. Sometimes you have a box that lets you reconfigure for different voltages for different RPMs, and that would be interesting if that's the case. I don't know if I can find it quickly here. Oh, this is kind of maybe similar. Sometimes you pull the cover off the side of an industrial motor and you can reconfigure it for different voltages. Still, I don't understand how it's not a number divisible by 3, but maybe I think I saw a schematic here that gets me close to understanding that. So anyways, at this point, I have to do a little digging before I go too far. I have to think about this for a bit. Changing the RPM per volt does have potential to help me get where I want to go. So I don't want to go to a higher kV motor. I want to, would it be higher kV? Higher kV motor and be higher RPM for the same volt. That would be beneficial, because I'm running a ton of field weakening to get to the speeds I want to spin this at. So basically, if I can run less field weakening and then run dual controllers to this motor, maybe that's an option. So we'll see. I'll try and get there. I'm going to try and wrap my head around this winding configuration and probably do a bit of research. But yeah, inside of each of these green connections, so there was 8 of them in total, 4 on each side, there's 2 groups of wires like this. So I'm going to stop there for now and try and understand this and then come back.